Welcome to AP Daily Video, Topic 7.1, Introduction to Natural Selection. My name is Tanea Hibbler, and I teach at Brophy College Preparatory here in Phoenix, Arizona. I'm here to let you know that you can do this. What will we learn today? So, what is natural selection? What factors influence natural selection? And how does natural selection affect populations? Natural selection is a major mechanism of evolution. It's what drives evolution. Evolution is a change in the genetic makeup of a population over time, and it's supported by multiple lines of evidence. Natural selection is a process by which organisms having adaptations that are suited for a particular environment have a greater chance of survival and reproduction, thereby passing those adaptations on to subsequent generations. Charles Darwin, here to the right, is mainly credited with the development of the theory of natural selection. There are several conditions that must be met for evolution by natural selection, so we'll talk about a few of those today. First, there's competition for limited resources. Not all organisms in a population have the same chance for survival. Competition is when organisms are struggling with other organisms to get limited resources. Organisms will compete for resources like space, food, mates, nutrients, and light. Differences in the phenotypes of these organisms will determine how competitive the organism is. This can lead to differential survival. So there's more born than survive. Favorable phenotypes can improve chances of survival. And there's typically variation in a population. Variation refers to genetic differences among organisms within a population, as we see to the right. Not all the individuals look the same. Mutations and sexual reproduction can increase variations within populations. Adaptations are the traits that provide an advantage in a particular environment. And individuals with adaptations have a greater chance of survival and reproduction. The number of individuals within a population having adaptations can increase over time. Evolutionary fitness is measured by reproductive success. So fitness refers to the ability of an organism to survive and produce fertile, viable offspring. Reproductive success refers to the production of offspring. And reproductive success over several generations is a component of evolutionary fitness. Heritability is the ability to pass on adaptations to successive generations. Due to selection, the traits of individuals that have more reproductive success become more common in the population. The reproductive success and the heritability of adaptations contribute to evolutionary fitness. Ecosystem stability determines the rate and the direction of evolution. There are biotic and abiotic environments. They can remain more or less stable. Environments can experience major disruptions and they can change quickly or they can change slowly over time. And I have examples here to the right. So populations are less likely to evolve in environments that remain stable over a long period of time. So in this stable ecosystem, you can see the environment's not changing, and as a result, the population's not changing either. On the bottom, though, we have a more unstable environment. So the more unstable, the faster the rate of evolution. So here you can see this fast-changing ecosystem. The habitat has changed, and as a result, the population has also changed. Let's look at an example. Evolution leads to quiet crickets in Kauai. So in this population, there was variation. The males have specially shaped wings. These male crickets have specially shaped wings with a scraper and teeth that produce a chirp when they're rubbed together. But due to a random mutation, some male crickets in the population have a mutation in their wings, and so they're silent like the females in the population. Both of these traits are heritable, so they can be passed on to successive generations. And there's competition that's happening within the population as well. Males are competing for mates, and chirping males traditionally have had more reproductive success. And then biotic factors. So what happened in this particular environment to change the population? On one of the islands in Hawaii, on Kauai, there was an invasive fly species that lays maggots on the back of the crickets, parasitoid maggots. The maggots burrow into the crickets and they emerge a week later, killing the cricket in the process. The flies use a sound to locate the crickets. So, as a result of natural selection, the silent male crickets are more likely to survive to reproduce because the flies can't find them to lay eggs on. So over time, this population became more silent. Silent males now make up 96% of the population of males. It's a great example. Let's go ahead and practice. The lesson skill focus is visual representation. Describe characteristics of a biological concept, process, or model represented visually. So go ahead and pause your video here. Please make sure you look at the diagram, read the labels, read the question, and then select the best answer. Okay. Did you select answer C? Which of the following statements best describes the change in the tree sparrow population? Tree sparrows with lower body masses were less likely to survive and reproduce after the snowstorm. So this is an example of directional selection. What should we take away from today's lesson? Natural selection is the process whereby organisms with adaptations suited for a particular environment will have a higher chance of survival. Natural selection is influenced by environmental stability, genetic variation, adaptations, and fitness. And natural selection can result in an increase or a decrease of specific phenotypes within a population over time. Thank you so much for joining me today. And remember that you can do this.